Hello. Hello. Hi, Paresh. How are you? I'm good. I'm good.
Sachin, can we quickly introduce ourselves? First, you can start, and then I'll go.
Sure. Hi, my name is Sachin. I'm a full stack engineer. I have 5.9 years of experience. I have been building mobile and web applications in React, Node, Next.js, Python side. I've built things with Django, Flask, and FastAPI. And currently, I am leading a team of 3 engineers at Finsoft, where we are building a sentiment analysis product. And yeah, I manage end-to-end development here alongside the team. Yeah.
Got it. Cool. So I'll just quickly introduce myself. I'm Paresh Dave. I'm working as an engineering manager over here at Redis. I have been working with Redis since 4 years, primarily working on stack like Java, Java, Golang, PHP, and have also worked on front-end development, including React.js libraries.
Yeah.
Primarily domain and I've worked in across the years is affordability, which is used for this EMI payments, business offers that you see, right? Then banking domain, cross-border. Overall, I have some 9.5 years in the industry, and I've been working on various payment products. Previously, I worked with the bank as well for 5 years, and then I joined Razorpay. So yeah, that's pretty much about me. We'll just start with this particular interview. As you are aware that this is a machine coding extension round.
Yes.
Machine coding extension round consists of you must have got a problem statement which you have solved, right?
Yes.
On I think or some portal. Now what we will do is we'll just cover the extension of that specific use case which you have already developed.
Okay.
That's what we'll do. So you can share your screen. Just open the portal and the details that you have received over the email, and we will. Yeah, you were saying something.
Yes. So I mean, I'll have to open the. 1 second. Huh? Yeah. Okay.
Just don't start the test immediately. Start it once I confirm. Because there is a timer of 1 hour, right? So you should not start it.
But I'm not sure. Like, I mean, I have to complete the test that is already completed. Like, how is this?
Yeah, that is already completed. Now we will do an extension round of that. So in the same code, you will have to do.
Okay, this one, right? Yes.
Yeah. Can you share? Yeah, I'm not able to see your screen.
You can see my. Okay, great. Now it is visible.
Now I can see. Yes.
Okay.
Just go to setup test.
Yes.
Okay. Do you have the code that you have written earlier in this particular test which you have given?
I mean, I had it in the link only, but I'm not sure if it will open or something.
Okay, just try to open it.
Yeah.
You can close this window. That's fine.
Okay.
Yeah.
Yes.
Acha, it will start up. Cool. Cool. Then we'll just pick up the. So I think you have worked on this window, sliding window rate limiter, right?
Yes,
So
sliding window. I got one. Yes.
Yeah, there will be multiple extension questions over here. I think we'll see which one comes to your screen, and we will work on that. So
Okay.
that's fine. We'll just we will just take 5 minutes to explain what you have coded in the previous solution, and then how can we extend it to meet the existing use case. Okay.
Sure.
The primary evaluation criteria over here will be that how extensible is your code which you have written already for the use cases. Okay. So you understand the solid principles, I believe.
Yes.
Right?
Yes.
And as part of the solid principles, like code extensibility and modifications have some control and constraints, right? Because if you go to an existing code base and you make some changes, it is expected that minimal changes needs to be done, and the code needs to be written in an extensible manner. That is the idea. So this will be the evaluation criteria primarily over here.
Yeah. Okay.
Just go to that screen once. Yeah, you can start the test now. Total number of questions will be 2. Okay, cool. You should just start once.
So it has to be like I have to memorize what I've done already, or it is like something I like I can just.
What you can do. So it's not like necessary that you the files which are written, right? They are fresh files only. So you can basically start a fresh solution only.
Yeah.
But yes, what you did earlier, you can continue from there as well. I'm sure you must be having the code written already, right? So you can continue from there as well. And if you are thinking like what kind of modifications you think should be done over here, etc., that you can just discuss with me.
Got it. Got it. Got it. Let me just walk over the question first.
Sure.
Okay.
What are you trying to achieve by queuing? Will this reduce the complexity of a solution, or what are you thinking exactly?
Yes, just to reduce the complexity of the solution.
Yeah. Okay. And how will queuing help over there? Your shift operation will be removed completely?
Shift operation can be, let's say if we, so basically shifting means we are shifting all the elements, right? Then we have to create a new array in that case. Let's say if we don't want to shift all these to the same request, right? Request array, then we can just clip the array basically, we can omit the first item and then bring the remaining ones. So something like slice.
Okay, but that would also be having some space complexity and time complexity associated, right? What would be the updated time complexity?
I mean, internally, I'm not sure how it is doing. So if it is doing like pushing all these elements one by one, then again we are not solving this problem actually. So it will become again O of n in that case if you remove even one item. And again, time complexity will, space complexity will also increase because we are adding into creating a new array out of nowhere.
When you think of something in that direction, and are you able to get some ideas what can help the scale? Because any solution that you build, right, as a lead engineer, you should be architecting it towards achieving scale, basically.
Yes.
Right? Especially in orgs like FastAPI, scale is of prime importance for lead engineers.
Yes.
Right.
Yes.
So how do we ensure and design it in such a manner that you will be able to achieve scale?
Yes.
Because you are queuing, the queuing approach is not able to reduce our time complexity, and I'm sure O of n square will never be able to take us to the scale that we want, right?
Yes. Yes.
So some kind of solution has to be built, right, in which you will be able to achieve scale and achieve scale of at least 10,000 TPS of transactions. So when you have 10,000 TPS of transactions just for payments, then with other operations which are added, and rate limiting would be applicable for all the kind of requests that is like coming, right? Authorization, authentication, doing the payment, verifying the payment, right? So how will you handle that?
I think concurrency will improve the throughput, but the algorithmic complexity of O of n, that is the bottleneck here actually. And talking about this one, I was considering that this will not be a problem because we already have a set of limits that should not be too much for one single user in ideal world.
What is the maximum number of limits that you can handle as part of this particular solution without impacting on your performance?
5 or 10 limits, let's say, I don't know, like, because we keep on, let's say for 1 minute we can define, for 1 hour we can define, for a very shorter period we can also define the same thing. But there should not be more number of limits because each of them is going to handle individually at any point. So limit wise it should not be a big array as such. But
okay. So for all this particular O of n square solution for your limit check, and let's say you have 1 billion users who are using this, right, with the concurrency of let's say 100 million users.
Yeah.
Will your solution be able to scale?
Yes. So this is where the shift thing is coming up. So it's like no, it will not scale. So in memory will not scale basically. But let's say we have a distributed caching or something that could handle all these concurrent users. Let's say this is one piece of code, right? It has its own caching, and there are multiple processes running to handle such concurrency, and we can handle that one. Let's say if this is not a shift operation, this is like a normal map lookup, then it is going to be linear, constant time complexity, and that can be done by Redis if we cache this data. Caching seems like a good solution, but this particular implementation will, so if you have to develop it for the scale, then for sure you have to build it like a more instances than just one to handle that case basically.
Understood. Cool. I think you can submit the solution, and for the other problem statement also, you can just copy this code and submit the same solution.
Is
because
this
the same question repeated to some reason.
okay? Is this copyable? I'm not.
Yeah, it is. It can be copied. First, submit the first one.
Okay.
Cool. I think both are submitted, right? You can end the test.
Okay.
Cool. I think Sachin, that's it from my side. You have anything for me? Any questions?
Yeah, you can tell me more about the role. I mean, what kind of complexity will I be dealing with?
The lead software engineer role at FastAPI is of a very high complexity. Okay, first of all, it's not only technical complexity. It is definitely technical complexity plays the major role over here because we are a microservice-based organization, and primarily all the services are written. All the solutions that we develop, they are solved via microservices. We have more than I think 900 to 1,000 microservices, like smaller across the org. Basically, it's a quite big org, right? So multiple services are there. So whenever we are building or developing a solution, the lead engineers play the primary architect role over here, and they ensure that all the information that is needed, or like what is there currently, what solution is already present currently, how that can be reused, what kind of new solutions are required to be built, right? They play as the title suggests, they play a lead role over here, and they will be required to handle high level of ambiguity whenever they develop some such kind of solutions. At the same time, mentoring juniors in their respective pods. So the usual pod sizes over here are for 4, 5, 6 people, like that. It usually happens, and leads are primarily responsible for holding the technical fort of that entire pod, right? Mentoring juniors at the same time, and resolving the blockers, helping them with tasks, etc. All of this is the primary responsibility of the lead. So it's a quite important and critical charter, whenever it comes to lead software engineer, be it any pod, any domain, anywhere you work. So, but yeah, these are the primary responsibilities that you will be looking after, provided you you join as a leader. That's the point.
Makes sense.
Specific questions you have with respect to responsibility or anything else?
Yeah, I mean, I'm clear on that. Like the scale, I understand that, of course, it is going to be huge. Yes. Yeah, I mean, I'm clear so far on this. Yeah, Paresh.
Cool, perfect.
Yeah.
Cool then. Nice speaking to you, Sachin.
Same,
have a great day.
Yeah, you too. Bye.